So yeah, I want to start off first by thanking the organizers. It was really awesome, especially whoever does the GDG Boston tweets and said that I was going to deliver my presentation because I work for GrubHub. It was really good. It was. I'm just going to put that. It was really good. I really liked it. So yeah, just about me. My name is Nick. We've already been through that. Worked out here for the company Level Up, if any of you know, local Boston company, and we got acquired by GrubHub, I believe, last year. So I've been working with them for a while. I guess a little bit more about me. Start off with a joke. How do you tell if somebody does CrossFit or is an Arch Linux user? Don't worry, they'll tell you. So I use Arch Linux, and that's, so yeah, also, lastly, just really quick, just want to put a quick plug. We do have some Android developer positions, so hiring is a whole word, so if you want to take a look at that, you can also always go to the GrubHub website, or hey, if you want to talk to me about it, cool. Or if you don't like me and you're like, I don't want to do that, cool, no hard feelings. So, into the meat of things, we want to talk about avoiding Kava. We got a little bit of a basic rundown on what that means, but I wanted to talk about what Kava is to kind of start off. Kava is a drink that's made from a root that comes from the Polynesian word for bitter, cure-all equivalent to alcohol, psychedelics, that kind of stuff. You want to avoid it. It's not good. These are the wrong slides. Hang on. One sec. Okay, cool. All right, we're on the right side. Okay. What is Kava? So, sorry, that was a really dumb joke. I appreciate you here working me through all that. I guess since we're actually starting the presentation now, I'll just kind of say what I want to do with this presentation. This isn't a me talking at you. I feel like I know a lot about this, but that doesn't necessarily make me the expert. If you have something that you want to add, like, feel free to interrupt me, especially because I don't know if I can fill up a whole hour. So anything that you can do to interrupt me would mean that we can all work together to fill the time that I have allotted to do this talk. Thank you. Anyway, what I want to do is, this is supposed to be more, I don't know, thought-provoking is the right term, but there's going to be some examples, there's going to be some stuff we can talk about, there's going to be maybe a little bit of audience participation. I don't have anything to like throw at you for prizes, but anyway, what we learned at specifically the level up side of GrubHub, we've been doing some very major overhauling. We have a gigantic shared SDK that we use for hundreds of apps, and we're creating all new features in Kotlin. We're converting stuff that's been done in Kotlin. These are gigantic efforts. And I've done some apps on my own. There's a lot to be learned, I think, from those experiences. Specifically, what I want to talk about is this idea of using what we've learned in Java in Kotlin incorrectly, and creating this new bad language called Kava. So that's just a really quick overview on that, and I want to start off by asking some questions. This is audience participation time. Who knows when Java 7 was released?
2009.
Close. 2011. That was close. All right, we got redemption time. Java 8. What is it? 2014. Close. Again, close. These are very, very old dates, but these dates are relevant, especially to, I believe, the majority of people using Kotlin as Android developers. These numbers are very, very important in Android. Most of us are probably, even if you're making new apps, probably still stuck on Java 8 stuff. There's stuff that, I say stuff a lot, but there's stuff that Android has released to bring in features from Java 9, Java 10, but in general, we're still kind of chained to Java 7, Java 8. We can have some features even sometimes all the way back to Java 6 if your app is old enough. Then we're also talking about the Bible of Java, Effective Java 2nd edition, written by Josh Block. That was released in 2008, before Java 7, which is the base for a lot of Android apps, was even written. So there's a lot of history with Java, and specifically with Android developers, we're kind of chained down to some older versions sometimes. That's why we get into this place that we need to break out of that and start stopping. We need to not be Java developers that write Kotlin. We need to be Kotlin developers that write Kotlin. So we'll go over a few things on that, but we want to start talking about, okay then, what is Kotlin? Kotlin is basically Java. Yes, no. Yes, but no. Obviously, this is what we kind of go into it. We were given this language as a gift, saying, this is like Java, only better, guys. Like, just look at all the simplification that you can do as a Java developer. But that was a great way to get into it. But now that we're into it a little bit more, let's figure out exactly what Kotlin is other than a better Java. That makes sense. Anyway, let's jump into there. I want to talk about what works really well about Kotlin. I only have a few bullet points on this. I don't want to get too much into this before we start getting into the examples of Kava, but there are a few things I picked out that I really, really enjoy about Kotlin that we don't necessarily have with Java. Probably one of the biggest things is the interoperability. It's a word, I promise, with the IDE. They bring so much down from the runtime into compile time and into lib checks, and that is so great for us. We already know this, but obviously it's because JetBrains makes the IDE too. This is something that, they bring so many things down into the level where we don't even have to build the app to determine whether or not we're going to have an issue. It's awesome. You don't have that in Java. There's a lot of guesswork. You do have it in some places in Java. Please don't correct me. I'll correct myself. Anyway, another amazing thing I know there's a Java X library, so just let's ignore that for a second and talk about how Kotlin X is the only extension library. But obviously it's first-party support. There's a ton of awesome stuff in there, and I believe, and I think they've already started doing a little bit, but this is a place where JetBrains can introduce concepts that will make its way into the core language in later versions. And this library being built with first-party support, having non-alpha releases of features that could be considered in beta, it's a fantastic way to going. And then lastly, Java compatibility. This is kind of a double-edged sword though, because you don't have to adopt all the language at once, but it does put you in that position of having hybrid stuff, especially when working with the automatic converter. I'll touch on that just a little bit. So I'm getting all my ticks out of the way in advance so that later in the presentation you'll be like, wow, this guy's really good at this. So, again, we asked the question, what is Kotlin? I want to bring out 4 points that I'll touch on. I've got some examples, I've got some thought-provoking stuff, might ask you some questions. First, I want to talk about what Kotlin is. Kotlin is simplified, clean, and boilerplate free. Removing boilerplate is not always a great thing, especially if it's not done well, or if you don't know how it's done in the first place. There's a lot of older Android libraries that I've seen people introduce that use annotation processing to get rid of some form of boilerplate. But we don't really know necessarily what's done under the hood sometimes. Sometimes we just adopt it and go, hey, this is done. But Kotlin lets us actually decompile what's going on, look at the bytecode, look at the generated Java code, so that we know when they remove boilerplate that they're actually doing a really efficient job, and we can check our own work, or their work, as it were. No check exceptions. This is kind of one that goes under the radar sometimes. If you know about this, you'll know why this is a big deal. I'll touch on it just a little bit, but this was an explicit decision by the Kotlin team, and there are reasons for it, there are reasons I can agree with, but I find it interesting because they bring so much down into pre-compiled, pre-run, but not exceptions. That they push back into runtime, whereas Java does the exact opposite. So again, we're looking at how we have this thought of Kotlin's a better Java, but they are actually actively changing how they do things instead of just trying to find ways to fix it and make it better. Again, I'll go into specifics on that. These are the bullet points. This is the table of contents for what I'll go through. Null safety, obviously, null pointer exceptions are bad, but I could spend an hour just arguing with people about null and non-null and everything all about that. We'll go through a few examples, but one thing in particular that I do want to make sure that we all agree on is null safety only works if you write it to be null safe. If you run it through the automatic converter, things aren't safe. There'll be a couple examples, obviously we've seen it, but I just want to point out a couple of things. Let's get the brain juice flowing, as it were, and see what we come up with on the other side. Then lastly, I'll go on about some of the helpers. We, as Java developers, wrote a lot of helpers with classes that needed them and make our lives easier. But Kotlin took a lot of those and put those right in the language. And there will be times where we'll be using a collection of some sort or some form of variable, some form of loop, and we'll automatically go to how did I write that in Java, write it out, rather than just find the implementation that's already there in Kotlin. I've done it many times. If you have never done that, then I actually really respect you. That's amazing. I don't know how you do it. But I talk fast. I apologize. I'm going to slow a little bit. Java gives us a lot of helpers, but as you can see, I do have some caveats on the bottom. These helpers can also make things worse if you use them wrong. So something to keep an eye out for as we move forward. So first thing, simplified, clean, boilerplate free. Let's look at Effective Java. This is Effective Java 2nd edition. I know the 3rd edition has been released, and I have not read it yet, even though I own it. But this was something that it's one of the very first items. Consider a builder when faced with many construction parameters, and the bolded out terms that he puts in there are, telescoping construction pattern works, but it is hard to write client code when there are many parameters and harder still to read it. It makes sense, everything is fine. So when we take a look at what that means, just as examples, obviously this is not super large, I apologize. The specifics are not important, it's more the generality. But this was just a test class I threw together. Obviously it's not a real class because you wouldn't name your variables 1, 2, and 3 and then assign them the values of 1, 2, and 3, that's just dumb. But what this is showcasing here is that telescoping constructor fall through what you would normally write in this case in Java. And then next to it, we have the builder pattern, which is much larger in the object, but the builder is actually much easier to read. It's, if you haven't built one of these before, obviously I'm assuming most of you have, but it's a good thing to see. This is also a good time to side note, I am using the dark theme in the IDE. There is a correlation between people who use light theme in the IDE and people who are sociopaths. Not saying everybody who uses it is, but I'm just saying you want to be on that side of history. Anyway, so when we take a look at, though, how we do things in Kotlin on these, as long as the variables are named correctly, that entire item of effective Java becomes completely irrelevant because of the name parameter constructors. This is obviously a pretty straightforward example, pretty crummy as far as what actual code would be, but that is just what I was meaning with this first point of, we hopefully all have read Effective Java or have been taught something from the Effective Java books, and there has been revision on Effective Java, but Kotlin handles a lot of these things for us. This wasn't an item about efficiency of code, this was an item about efficiency of reading and writing the code, and we fixed it just by using Kotlin. So if you were to automatically convert this file with the builder, it would build it for you. You'd have a builder, everything would be fine. But if you do it this way, it's better. See? We're thinking now. We're thinking. And that's what's important. So, moving on to the next one. Hey, any questions? Yeah, no, that's fine. So next item was exceptions, and the line that I use at the beginning is Kotlin does not have checked exceptions, and basically that just means that if you write this thing, this appender is an actual implementation from Java that String Builder uses. If you try to access append, there is a unhandled IO exception. So how do we handle this? Unhandled. We handle it. It's handled now, right? We have done it. There is now no more error. This is bad, obviously. This is effective Java. You see, I did read the 3rd edition. This is item number 77. Don't ignore exceptions. I'll be honest, though, I didn't read all the way to number 77. This comes directly from Kotlin's website. The Kotlin Lang, they go into a lot of detail about this. If you specifically want to get into the nuts and bolts of why they don't check exceptions, those kind of things, this is why. This is a forcing factor for us as developers to not just handle exceptions because they won't compile if they're there. It's pretty straightforward, but at the same time, I've seen this catch people off guard. You go here and you're like, hey, this isn't throwing an exception. How am I supposed to know? Well, you're supposed to know by writing your code better, maybe? I don't know. That's what they say anyway. There's a lot of, like I said, there's not a clear answer, I think, for this one. I do agree with them that this is bad. However, I'm not sure if I agree with them that necessarily crashing at runtime is better. Because that's obviously what we're avoiding here is a crash. But I think in the long term what they want us to do is rather than just handle errors and exceptions, want us to fix what would happen. Like, what is the expected result? Obviously, we don't want it to crash, but what's the expected result if this fails? Some form of moving forward from that. So I'm not going to go into and try to act like I know how Kotlin was written, but that seems pretty straightforward. So.
But this is exactly what you will have in Kotlin, if you need to handle exceptions here.
Yes, but
so
it will.
It's not better.
It's not better, but it's pushing it again from you can compile without catching the without doing a try-catch block, and it will fail in runtime instead of in compile time. And so
I don't think it's better.
You'll still exactly Is it better? Is it worse? I think it's the same, right? But it's where we handle it, and it's a forcing factor on handling it correctly. Instead of just saying, okay, I'm going to try catch this so that I can compile the code. I don't care what happens. Instead, if the crash actually happens, you can then respond and say, how should this act if the crash happens? I think, especially as mobile developers, I think our biggest fear, our biggest thing that we're going against is crashes. But sometimes a crash is better than nothing happening at all. So there's that question of, let's say this appender executed something, right? It brings the user to the next page. It'll crash if they try to do it. That's bad. It'll do nothing if you do this. Is that worse? Which is worse for the user, a crash or nothing happening? And that's, again, I don't think there's an answer for that one. I don't think one's necessarily better, but.
I won't take much more time, but I would put here just at least logging.
Mm-hmm.
So at least I will know that the exception was thrown, and IO exception, it just has a message, so I would have a message from that.
You'll log it, and then never look at those logs again.
It's fine. It's fine. If I'm curious, if I need to figure out what's going on in this particular problem, I will have something, because this, obviously, and this is the worst, obviously, but Kotlin doesn't help with that, other than it won't bother me with that until it's actually crashed.
Yeah, so exactly what you said, Kotlin doesn't fix this, and that's absolutely accurate. I think what they want you to do, and if you read through the documentation, they put specifically on check exceptions, I think that rather than attacking this as, I want to put a log here and see why this happened, instead I think that they want to say, well, why log it? Why not just handle any error that's coming in the way that you would do it, and not have to have this kind of temporary space of, ooh, this code says that there might be a crash, so I'm just going to put logging around it. But there's not a right answer. I don't think.
Sorry, but this is when it's a checked exception, then developer knows that exception might happen. Without checked exception, I have no clue that it might throw exception. And this is a problem.
I'll add one thing. 10 years ago, I don't remember an article now, C#, right, as they came out, deliberate decision, no check exceptions versus Java. Right? I don't know what the rationale was in the whole article they wrote about it, the actual author of C#, why he went against check exceptions at runtime. But I think they won the argument. Over 10 years, they said, look, C# is a better language. We liked it. We don't have check exceptions. Java has it for the exceptions.
Yeah, this is a Kotlin conference. C# is a garbage language, but no, I'm just kidding.
So I think
Don't worry.
well, so there's an argument there by the actual author of C#. I'm reading an article, so it's moving that. It'd be good to read about it. So I think it's really, that's what I've been trying to do. It's a proven language, C# does it. Most modern language will not have check exceptions. And yeah, your point's right. Like when I look at code in production, I would better have something log that I can find the root cause of and have nothing.
I know why, and I don't think that we should take time of this presentation to that. I did talk with whatever, I don't remember the name, I'm terrible with name, with the guy who developed actually Kotlin, and he said that he didn't actually think about the exception, he just take it from Java, get rid of checked exception, and that's it. So he probably, hopefully, thinking about how to do, how to handle, how to deal with exceptions.
Yeah, the only reason I bring this up is and again, I agree, absolutely. Like there's not necessarily a right answer. This isn't necessarily solve anything. It's changing where you would encounter it and how you would encounter it. And the reason that I've actually brought this one up was because as we were doing work, somebody came in and says, hey, I'm converting this file to Kotlin, and now all of a sudden it doesn't tell me that there's going to be an exception. Like, what do I do here? And that was the answer. The answer was, well, this is Kotlin, so you don't do anything. This is Kotlin, so you need to figure out what would happen if that exception were actually thrown rather than just do it. So again, it's not going to solve anything. It's just going to change how we approach those problems.
Guess
and
what?
again, this could still be the right approach.
Guess what? I will
Without the
put
do nothing,
throwable
actually
here.
log it. But
I will put throwable here if I don't want any exception. I will put throwable here, and then I back to the same situation.
But it'll still compile. That's the difference. But so yeah, anyway, I do appreciate you bring it up. It's obviously a big conversation. Kotlin isn't the first language to do non-checked exceptions, but I do find their take on it in their documentation. I found it very interesting. They specifically brought up this item of effective Java. They wanted to make sure that it was not something that we just ignore because it's there. They want to make sure that they actually actively do it. And they thought this was the reason why. But yeah, I don't think there's right answer. I guess I'm anything else. Happy to check exceptions. Is again, I thought nullability would be the one that we'd be arguing about, but I'm fine with arguing. That's fine. So I guess. Hey, I think I had like a half hour, man, and I've only got like 2 slides. No, so I guess we're gonna just same. We'll have more arguments, I'm sure, about Kotlin versus Null. And Null is a big question, especially as Java developers. We avoid Null, but I think there's one way that we can all avoid Null together, and that is latent init. Latent init is a fantastic property, especially if you're using an older version of a dependency injection framework, sometimes view models. Obviously, something like Coin would not really be applicable here because they use their own kind of the by keyword to automatically put stuff in. But you're talking about an Android framework. You don't create activities with variables. Sometimes those don't get generated. The values don't get generated until the on start, and you're going to use them and on create. You know that they're there. Latent init allows you to sign that contract with Kotlin and say, yeah, there's no value here, but I promise by the time I get to it, there will be. And especially working with a framework like Android, I think this is a fantastic property that can be used because there are so many lifecycle hooks that if you know by the time you hit on create, you've already generated it in on start, what other way around. I don't act like I understand the lifecycle, okay? I just know it exists. But there is a problem on this. Let's say this item, turns out actually this item can be null. Easy. We just laid init var the string for null. Except that doesn't work. Laid init cannot be placed on a nullable property. Does anybody know why? Exactly. So again, this is a Java concept in a Kotlin world. This variable now can have a null value. So we say, okay, it's a laid init null, but that doesn't work because if something's nullable, it needs to have a default value of null if you are not going to set a value to it. So again, this is pretty straightforward stuff, I know, but again, this is a Java concept that we're now pulling into this language, making small changes that this actually comes up on Stack Overflow quite frequently. If you search laid init var for null string, it actually comes up. So this is a common misconception of, again, Java and Kotlin are not the same. So that's just a little small example. I've got more stuff. But first, let's ask a question. This is sure to start something, I'm sure. Is null bad? Come on, don't cop out on it depends. It's true though. It absolutely depends. But coming in from Java, null is almost always bad. You should have some form of value. But I want to posit no value versus an empty value, right? These are obviously two different. I'm not going to patronize anybody, but this can change how you access data flow. If you have a nullable value, that can be like a string, that can be an empty string or some content. This can change, let's say, as a very small example, this is a user input field. It is null. The user has not input anything. If it is an empty string, the user has inputted nothing. So then you don't have to have a Boolean asking whether or not the user has input a value there, or has been shown this. The value's there, it's empty. You know the user has put something in, it is nothing. Very bad example, I know, but the data flow is what's important. You were considering null as its own state in a very light form of quantum computing. I'm not saying we're quantum computers, I'm not saying Kotlin is a quantum language, but if a value can be empty or full or non-existent, you're seeing how there's three states now instead of just two. So, again, I'm not going to act like I'm going to blow everybody's mind with quantum computing and Kotlin. I have no idea how that works. But we're thinking here, we're thinking how can null be used as a way to make our data flow. So, and that's how that is. But let me talk about this for a second. Thank you. Come on, guys. I made a really, really good joke here, and you are not appreciating it. All right. Let is great. We've all used it, I'm sure. This is fine, but again, the problem is taking let into account with a null safe operator, question mark, in a way that maybe you don't really know what you're doing. And look, you can make fun of me as much as you want here. I actually did this, so please, please, please. This was the Java version, and this is what I wrote when I first adopted Kotlin into rewriting this activity. I have a feeling the autoconverter had a little bit to do with it, but it works. This snack bar might be null. If it's not null, then let's work with that Boolean. And the null safe parameter passes it down, so it is shown to be null safe, and then we access the snack bar only if it's not null. Obviously, context is important, so the more correct way to do it will be to make sure you keep the context of the property that you're accessing null safely. Let can be very good, and honestly, the null safe operator question mark itself, I feel like can be very dangerous if you don't know what you're stepping into, because you can just pass down a null value all the way until you've lost where you are. You don't even know which part was null in the first place, and now you don't know what context you're working with. So I encourage you to not use the autoconverter. more in depth than that in a little bit. The autoconverter is good sometimes, but this is what autoconverter did to me, and I'm trying to save. Anyway, speaking of the converter, let's take a look at something the converter did not do well. Now, I've talked with Jake Wharton directly about this. I don't know if you know this. Does anybody use Butterknife? Did you know that Butterknife started off as a joke, and Jake hates it? it's quite entertaining, actually, to hear him talk about it. He made Butterknife as a joke, and then people started using it, and he was like, oh shit, I better do something about this. So, so before Kotlin and the synthetic injection properties came into place, I used Butterknife everywhere. It was so much easier than doing 5U by D, everything. And obviously now, synthetic injection works just as well as Butterknife did. But when I auto-converted it, it gave some issues. Obviously, the Kotlin autoconverter is not aware that I was using Butterknife, or in the case of the 2 items above, I was using Dagger. It was not aware that I was using those commands in the onCreate to make those variables exist, and so they called them nullable rather than using latent, as I mentioned earlier. Of course, there's no way that the converter could have known that I was using it in these situations, but this is a pretty large chunk of the file that I now have to rewrite to be more correct. That, I feel like, is going to be the major drawback to continuing to use this autoconverter, rather than taking the approach of reading the entire file and rewriting it in Kotlin. That's a lot. It's a lot, but if you've used the converter enough times, you know how much time goes into fixing its mistakes as well. I think that there's definitely diminishing returns on both sides, but that's kind of what this is just here to, you know, if I would have just taken a look at this without sending it to the converter, I would have immediately known, let's get rid of Butterknife, it doesn't need to be there. Let's change how we're doing dependency injection, make those latent invariants because they'll be there by the time dependency injection happens. All this kind of stuff to just point out that you need to be careful. Careful, right? So, I mean, obviously, this is, please don't judge my code. This is actual code that I wrote at one point in time, so, look, I needed examples. Don't give me any code on that. Anyway, lastly, for examples for null, bang bang. If you don't know what bang bang is, it's the colloquial term for double exclamation points, which is the assertion of something being non-null by the time you get there. Are these bad? Again, the answer is it depends. Didn't say it this time. No, so this was autoconverter. This is just one file. I pulled out every instance that the autoconverter put in. Bang bangs everywhere. And these are, again, this is, I believe, the same file actually as the one before. So here's more. Here's 50 more lines. I think I have another one here. No, I don't. 50 more lines of code that I now have to rewrite to be more correct based on Kotlin. Now, I honestly just wanted to sneak this meme in here. There's not really a lot that has to do with anything on this, but I don't know, this is kind of how I feel when I'm reading through a file with a bunch of nulls, with either the bang bangs or the null seek, and I feel like there is a kind of argument to be said for both of them. And a coworker of mine actually put this out there as code smell. Code smell is a term that I have never actually heard before, so I'm going to tell you what it is as if you have never heard it before. Code smell is something that can indicate that there may or may not be a problem with your code. These, I think, both are great indicators for code smell if you see them. Doesn't necessarily mean that they shouldn't be there. In fact, many times they should, but Kotlin does do a pretty good job determining if you check something for null before requiring that you use bang bang. And if something is chaining down a null save operator all the way down, maybe there's a way that it couldn't have been nullable in the first place. That's all I'm saying. That's all I'm saying. Again, we're not saying either of these are bad, but when I read them, this is how I feel. So just more the one on the right than anything. But yeah, again, I'm not saying there's a right or wrong answer here, and I'm not trying to pretend that I know there's always a right or wrong answer with these. There have been times where I've been required to use that because of the way that I check whether or not something's null. A really good example actually is Android's text utils. Text utils is empty, checks if it's null or if the string is empty. But it does not communicate that to the Kotlin compiler to let it know that it's been checked for null safety. So sometimes it's fine, sometimes it's not. You know, I'm not here to judge your life, man. Like, you do what you want, all right? Coming to this home stretch here, bear with me. We're talking about Kotlin helpers. I want to talk a little bit about for. Again, I'm not gonna say here, give a presentation on how to use all these. I'm assuming we've all been used these before. These examples are directly from the Kotlin website. I'm not going to teach you how to use them. But if we've been working in Java for 6, 7, 8, 10, 15 years, index loops were the way to go. And that was kind of thrown out the window with this. Obviously, you still can use the index to use a for loop in the way that it was done, but there's so much that you can do now with these operators that you don't have to do index loops anymore. It's a really good big reflex to go straight to it, especially because the index loops were ineffective Java 2nd edition, but this is a better way, I think, especially because if you do it this way, and Kotlin determines that there's a better way to compile it down to Java, it'll do it automatically for you, and you don't have to rewrite it later. Problem solved, right? But there's one problem with this screen. Are there any keen-eyed observers? Any Kotlin experts notice something wrong with this? No, because I'm so good that I've deceived all of you. Down to until it doesn't exist, I wrote that. So here we go, talking about these, what are they called? I don't know, functions. Anyway, again, this is another example of a Kotlin helper in a way that we're going back to that original item I talked about in Effective Java, making things easier to read and better to be accessible. There was no until for counting down, so I made one. So again, if you haven't used until, by the way, it's amazing because there have been so many times where I had an index loop and I didn't care about the last value. But this is just an easy way to put an entire function that does everything you want. You've already done the logic into a word that looks like it fits right in. It can be overdone. I've seen it. I've done it. But a lot of times you can use these inline functions to make your life easier. Have it in a shared file somewhere. You can share it with your team, and then your team hates you when they don't know what it means. Anyway, I hope that was a good. I tricked you, and I'm sorry. I apologize. It won't happen again. We'll move on together to collections. Collections are great because now we get to argue again. Mutable or immutable list, which one's better? Thank you. There it is. So obviously, mutable and immutable aren't new concepts with Kotlin, but the default state was definitely a bit jarring for me when I was first coming in. List of, which is a fantastic piece of ingenuity, automatically creates a immutable list by default, which means that if you want to do anything with it, they are, again, this is one of those Kotlin pushing you to do something, whether or not it's something that is necessarily correct to do, but rather than immediately being able to modify the list, they want you to copy the contents of the list into a new collection if you're going to add anything to them. Or you can say mutable list of, but nobody wants to do that. Anyway, and list of is just really great. Look at that. You see that? Creating a new list in Java is a pain in the ass. I just wanted to stop on that for a second. Moving on though, with these are more collection helpers that if you haven't used them, you absolutely should. Because there are ways to do it in your own major collection iterator ways, which by the way, most of these compile down to a JVM instance of iterator, so you don't have to worry about performance, and it's fantastic. But using the exact same lambda argument for find and filter, the predicate, if you will, because that's what it's actually called. You can either get just Nick or a list that contains Nick based on the exact same thing. So again, these are things that are built into the Kotlin language that if you're not looking for them, you might forget about, and you might go through and do your own iteration through a list to find things instead of just letting Kotlin do it for you. So, yeah, anyway. That was a way Kotlin. So I hope you have fun with me. I hope that we came together as a team and established what we can do to start the process of healing. Don't let Java hurt you again. Be Kotlin developers and not Java developers that also code in Kotlin. That's all. So, thank you. You know what? 13 minutes left to go. That's pretty good. I think we all did a really good job with that. So, I'm happy to, if there's any arguments, anybody wants to tell me I'm wrong about something, now's definitely the time.
Yeah, about the for.
Wrong about everything?
For loop. I find with all these extension functions, there is no need for for loop. You have the range, and you just map it.
Yeah, it's very true. Yeah, that's another that's something I was going to get to, but didn't because I forgot. But it was something that I when I was putting this together, I wanted to touch on. Is what you're saying is the for loop. You may not even need it anymore. These operators that you have on the collections let you do so much without even converting everything back into an array and sending it through a for loop and using until and removing the last one and creating a new inline function when instead you could just filter the list and you get the results that you want. There's even ways to, there's operators for ordering it in a different order if you want to do that, so you don't have to go through. And one of the things that I didn't touch on here, which is amazing, and it took me a long time to actually know this existed, so if you haven't gotten a chance to, you can name your while and for loops with annotations and break out of a nested one from the inside without having to go through and break out of each one individually. It's fantastic. I recommend you definitely, if you haven't, read through the Kotlin documentation. I know it's a lot. Like, don't get me wrong, it's a lot, but they have so many helper functions there that you wouldn't expect to exist. And that one in itself, I wasn't able to find the example, that's why I didn't put it in the slides. It saved me from, again, this could have been my fault in the first place, but I had 3 nested loops down that I was iterating through to find a value for this, value for that, and then return everything back. With Kotlin, I just named that first loop, and when I found it, it said break out of that loop, and it wrote everything for me to break out of everything without me having to individually exit and break out of every single loop going down the line and return the value I wanted. It was just a fantastic way of doing it. So definitely read through the Kotlin documentation. If you haven't, find all these helper methods. Find they explain their decisions on stuff like checked exceptions, on stuff like mutable, immutable lists. It's a great way to familiarize yourself with what they intended and really how to write that language and not write it as, again, not a language at all. I made up this word. I don't know if you knew this. Kava's not a real word. That's a lie. Sorry. I'm trying to deceive you again, and that's on me. I'm sorry, everybody. Yeah.
When planning to write good Kotlin, do you have any favorite resources that you can point us to? Like, apart from read the documentation, are there any good blog posts, articles that?
I wrote a few blog posts. No, that's actually something that I've had a lot of arguments about. Believe me, argue what? Because there has been a release of somebody publishing, I think it's just an ebook or maybe a blog series, but effective Kotlin. My argument is that it's too early for that, and I think it's also, I think Kotlin is too young to have somebody saying this is the correct way to do everything. And that's a non-answer, and I know that. I found that my biggest ways of establishing what the Kotlin stuff were was just figuring out what didn't work first and failing forward, because everybody has been continuing, I believe, to fail forward until we are now in a place where we understand the language a little bit better, because the documentation is going to have stuff like we talked about with, here's our intention. Our intention is that you don't check exceptions, and here's why. That doesn't really help you with writing it. And then you're going to have blog posts of people saying, well, here's how I wrote it. Then 6 months later, we'll find out, actually, that was done wrong, and now we've learned that. And it's kind of in this weird stage where I don't think there's one necessary resource that you can go to. It's definitely more of making sure you familiarize yourself with all of what the documentation has to offer, as far as making sure you're seeing these functions that exist in a Kotlin world that didn't exist in a Java world, and just using the shit out of it. I mean, sorry, language, I apologize. But I think that's definitely me being on one side of an argument, though. Definitely check out the effective Kotlin. That should be the name of the talk. Effective Kotlin that was very recently released. That would probably be a really good source. I just personally don't believe it with that. So yeah, that's I know again that's another non-answer, because that's what I do. You know, I let everybody else answer the questions for me. But yeah, I hope that at least you understand why I don't have an answer, because a lot of people think that I'm wrong when I say that it's too early to have effective Kotlin. They're like, no, it's never too early. But I'm thinking, well, Kotlin came out what? Last year? Feels like last year. I know it's been a long. How long ago was 2016? I don't want to think about it. Anyway, so yeah, that's I think the best answer would be to definitely check out effective Kotlin, but I would say take it with a grain of salt. That's just my personal opinion.
On top of all of that, because Kotlin very good with DSL, so one of the approach would be create DSL for yourself, and then if you create it well, then you would use DSL instead of the Kotlin.
DSL, of course, is an internet type.
DSL as a domain-specific language.
Yeah, that is one thing that I think can be helpful for a lot of people, is just how open Kotlin is and how you can do stuff like that. Obviously, there's ways to do it with other languages, but JetBrains has been really good about making sure that everything's available for everything, and that's why we have the multi-platform stuff that we have. Everything is working out fantastically with that. As an Arch Linux user, I can also download the compiler from the user repository. Guys, why aren't you on Linux yet? Why are you running around with Mac? Let's come on. We're Android developers.
I know.
Well, why are you getting? No, I'm just kidding.
Because it's the Kotlin, not on.
Yeah, no, it's true. It's very true. And that is something that obviously Kotlin has expanded its role in the world. So a lot of my assumptions were definitely wrapped around Android developers, and I do apologize for the non-Android developers out there. But I think we can agree the language kind of came from Android, so it can be a little bit of forgiveness.
Other way around.
I mean, the popularity of Kotlin came from the. That's what I meant to say. I apologize for that. So I hope there can be a little bit of forgiveness from me there for excluding our friendly multi-platform developers. So I think that's all I got. I got like 5 minutes to hang and eat coffee.
So one more addition. So you mentioned the annotation for labeling the loops and
Yeah.
So actually, Kotlin has this default parameters like it and this, just like in Java, and it also allows you to actually specify from which scope outside of the stack you want to use them. So you have it in 3 different scopes going in, and you can say this it is from there.
Yeah,
Also shouldn't
it's like a
overdo it.
reverse annotation where it's it at and then the name, and you'll see that the auto converter actually attempts to do that a lot. It never has worked. I've never once seen a named context variable been done correctly without completely crashing if I try to compile it. But if you do run the autoconverter, you may see what we're talking about with that. If you haven't seen it yet, it is basically it or this or some form of a context variable with an annotation sign and a name, usually like it's attempting to name it after the loop that's on top or something like that. But definitely, that one was really entertaining to go down that rabbit hole of those nesting hits.
Never overdo that. Absolutely.
Well, thanks for bearing with me. I hope it was at least fun, you know, and maybe you didn't learn anything because really that wasn't what this was intention was for this. But hopefully, like I said, we can move past Java together. We can heal and not have Java hurt us anymore. So, all right. Thanks everybody.